Okay, this one feels like we're watching cosmic history happen in real time. Imagine a star so big that if you placed it where our Sun is, it would stretch past the orbit of Jupiter. Not Mars. Not Earth. Jupiter. That's how enormous this star is. Its name is WOGI 64. WOGI 64 is not inside our Milky Way. It lives about 163,000 light-years away in a nearby satellite galaxy called the Large Magellanic Cloud. That means the light we see from it today actually left the star 163,000 years ago, when early humans were still sharing the planet with giant Ice Age animals. And this star is absolutely gigantic. WOGI 64 is about 1,540 times wider than our Sun. Let that sink in. If our Sun were a basketball, WOGI 64 would be a mountain. It has nearly 30 times the Sun's mass and shines with 282,000 times more brightness. For decades, astronomers classified it as a red supergiant, the same type of star as Betelgeuse, the famous reddish star in the constellation Orion. Red supergiants are massive stars near the end of their lives. They have burned through most of their nuclear fuel and expanded outward into enormous, bloated spheres. WOGI 64 was even stranger than most red supergiants. It was surrounded by a thick ring, or torus, of dense dust. Picture Saturn's rings, but made of heavy stellar debris. This dusty ring likely formed because the star has been shedding material into space, blowing off layers of itself as it struggles to remain stable. For years, that's how astronomers understood it. But then something changed. Around 2014, astronomers led by Gonzalo Muo Sanchez at the National Observatory of Athens noticed something unusual. The star's color began shifting. Its surface temperature started increasing. That might not sound dramatic at first, but for a giant star at the end of its life, that's a big deal. Red supergiants are cool compared to other massive stars. They look red because their surfaces are relatively cooler. But WOGI 64 began moving away from that red phase. It appeared to be transforming into something much rarer, a yellow hypergent. Yellow hypergents are extremely unstable stars. They are among the rarest types of stars in the entire universe. Only a handful are known, and they don't stay in that stage for long. Astronomically speaking, if red supergiants are elderly stars, yellow hypergents are stars in crisis. When a star becomes a yellow hypergent, it's usually because it's undergoing intense internal changes. Deep inside, nuclear fusion reactions are shifting. The star may be fusing heavier and heavier elements in its core. Its outer layers become unstable. It can pulse, eject material, and dramatically change brightness. It's like the star is struggling to hold itself together. This transformation is important because it may be a pre-supernova phase. Massive stars like WOGI 64 live fast and die violently. And like our Sun, which will gently fade into a white dwarf billions of years from now, a star with nearly 30 solar masses doesn't go quietly. When its core runs out of fuel, gravity wins. The core collapses in a fraction of a second. Temperatures skyrocket. Shockwaves rip outward. And the star explodes in one of the most powerful events in the universe, a supernova. For a brief time, it can outshine an entire galaxy. And what remains afterward? Often a black hole. That's why astronomers are so excited and cautious about WOGI 64. If this transformation into a yellow hypergent is real and permanent, we may be watching the final chapter of a massive star's life unfold. But here's the important part. We don't know when it will explode. It could happen tomorrow. It could happen thousands of years from now. Stellar evolution does not run on human schedules. The team studying WOGI-64 noticed that as its temperature increased, its spectrum, the fingerprint of light that tells us what elements are present, also changed. That suggests internal restructuring. The star isn't just fluctuating randomly. It's evolving, and that dusty torus round it, that might play a major role in what happens next. As massive stars approach supernova, they often shed enormous amounts of mass. The material forms shells or rings round them. If and when the star explodes, the supernova shockwave can slam into that surrounding material, creating incredibly bright displays. We've seen something similar before. When supernova 1987 exploded, also in the Large Magellanic Cloud, astronomers observed glowing rings of material round the explosion site. Those rings were ejected before the blast, likely during unstable late-life phases. WOGI-64 could be building a similar setup right now. But there's more mystery here. Yellow hypergents are rare because this stage is short-lived. Stars pass through it quickly, sometimes in just thousands of years. That's nothing in cosmic terms. It means we are lucky to observe one at all. Even more intriguing, WOGI-64 might not be alone. Some observations suggest it could be part of a binary system, meaning it may have a companion star. If true, interactions between the two stars could influence mass loss, dust formation, and even the timing of a future supernova. Binary interactions can dramatically change how stars evolve. They can strip material away, distort stellar shapes, and even alter the type of explosion that occurs. Right now, scientists describe WOGI-64's future evolution as uncertain. That's not a dramatic phrase, it's an honest one. Stars this massive don't always follow predictable paths. Some red supergiants explode directly. Others may shed so much mass that they evolve back toward hotter temperatures before exploding. Some may collapse almost silently into black holes with little visible explosion at all. If WOGI-64 does explode, it will be spectacular, but not dangerous to us. At 163,000 light-years away, it poses zero threat to Earth. Instead, it would become a brilliant point of light in the sky, visible even with small telescopes. And remember, if it explodes tomorrow, we won't know for 163,000 years. Because we are always looking into the past. That's one of the most mind-bending parts of astronomy. We are watching ancient light. What we're seeing now already happened. Somewhere in the Large Magellanic Cloud, the fate of WOGI-64 may already be decided. But from our vantage point, we're witnessing the transformation phase. A red supergiant shifting into the yellow hypergent. A cosmic giant entering instability. This is why massive stars matter so much. When they explode, they forge heavy elements, iron, nickel, gold, and scatter them into space. Those elements become part of new stars, new planets, and eventually life. The calcium in your bones, the iron in your blood. It was made in stars like this. So when astronomers say we might be watching a star die in real time, it's not just destruction. It's creation. WOGI-64 represents a rare opportunity to study the final, chaotic stages of stellar evolution. It allows scientists to test models, refine predictions, and understand how the most massive stars end their lives. And maybe, just maybe, someday future astronomers will witness its final explosion and confirm that this strange transformation was indeed the beginning of the end. Until then, WOGI-64 remains a cosmic question mark. A colossal star. A shifting identity. A possible future black hole. And a reminder that even the biggest giants in the universe cannot escape gravity forever. Somewhere, 163,000 light-years away, a Hypergent burns, unstable, unpredictable, and magnificent. And we're watching, and here's where things get even more fascinating. To understand what might happen next to WOGI-64, we have to zoom deep inside the star itself. Massive stars live very different lives compared to stars like our Sun. The Sun mainly fuses hydrogen into helium. It does this slowly and steadily, which is why it can shine for about 10 billion years. But a star like WOGI-64, it burns through fuel at an extreme rate. It's like a cosmic engine stuck at full throttle from birth. After hydrogen runs out in the core, the star begins fusing heavier elements. Helium becomes carbon. Carbon becomes neon. Neon becomes oxygen. Oxygen becomes silicon. And eventually, silicon becomes iron. And iron is the end of the line. And like lighter elements, fusing iron doesn't release energy. It actually consumes energy. So once an iron core forms, the star is living on borrowed time. There is no more outward pressure from fusion to fight against gravity. When that balance tips, gravity crushes the core inward in less than a second. For a star with nearly 30 times the Sun's mass, that collapse is catastrophic. The core may compress into something unbelievably dense, possibly forming a black hole. Meanwhile, the outer layers rebound in a violent explosion. That explosion is what we call a core collapse supernova. But here's the twist. Not all massive stars explode the same way. Some collapse and produce extremely bright supernovae. Others may collapse almost quietly, forming a black hole with only a faint burst of light. Astronomers are still trying to understand what determines the difference. WOGI-64's massive dusty ring could play a crucial role. If the star explodes while surrounded by thick layers of material it previously ejected, the blast wave would slam into that material. That interaction could make the supernova shine even brighter and last longer. It could become what scientists call a Type -1 supernova. One powered not just by the explosion itself, but by the collision between the blast and the surrounding gas. And remember, this star has already been shedding material. That torus of dust round it is proof that it has been unstable for some time. Another possibility that the yellow Hypergent phase is temporary. Some stars move back and forth between red and yellow stages depending on internal changes. WOGI-64 might not explode immediately. It could continue shedding mass, reshaping itself, and evolving further before the final collapse. What makes this so powerful for a science is timing. The yellow Hypergent phase is extremely short. If WOGI-64 is truly in this stage, astronomers may be catching it during a tiny window in its life, like photographing a lightning bolt at the exact moment it strikes. That's rare. Telescopes around the world will now monitor it closely. By studying its brightness, temperature changes, and spectral fingerprints, scientists can track how unstable it becomes over time. And if one day its light suddenly spikes dramatically before fading, that could be the first sign that the explosion has already happened, and the light is finally reaching us. Until then, WOGI-64 stands as one of the most extreme and unpredictable stars we've ever observed. A giant nearing its breaking point. And maybe, just maybe, a future black hole in the making.